Bits of this story might seem hauntingly familiar to some of you. Some of it might sound like your entire life. Any resemblance to real-life people or places is due to the fact that we at Qumulo have seen stories like this many times. Let me tell you the story of Really Big Studios. Really Big Studios resembles many smallish but growing studios, providing a variety of services to whomever will give them business. They do a little bit of everything. Really Big Studios had just landed a big project that could take the company into its next phase of growth. Meet Tony. Tony is the VP of Engineering of Really Big Studios. Recently, Tony was in the CEO's office with the CEO and CFO discussing this big new job. Tony was a bit concerned with his future as it related to this new job. If he could build out his whole environment properly and everything held together, the company would be able to handle the job. Handled properly, this big project would allow the facility to expand and hire more talent and acquire more equipment, which would facilitate a wider production pipeline, and that would lead to more profit. But, handled poorly, this big project would swamp the company, cause massive delays on other projects across the board, and damage the company's reputation as it missed deliveries. The stakes were pretty high. So Jacques is the CFO of Really Big Studios, and one of his jobs is to make sure money is not spent unwisely. To Tony, however, it sometimes seems like Jacques just likes to say no. Tony, under Jacques' constraints, has managed to put together an environment that works reasonably well for the low volume of work moving through the company right now. Because of the per-project nature of Tony's budgets, he's acquired a few different systems for a few different purposes. He's got a couple systems for editing, a machine farm for rendering, a few systems for the artists, a specialized system for color correction, one for audio, another for transcoding, and an archive system. And in most cases, with each of those systems, Tony acquired a little bit of storage along with it. Might be a NAS appliance, it might have been a SAN, it might be some disk in a file server somewhere, or a tape library. And there's a few problems with this environment as it stands today. You've got multiple disparate buckets of storage, and it's making capacity more difficult to manage. You've got people storing multiple copies of their data. You've got people buying individual USB drives. And this makes it very hard to find things. And it makes it very hard to know what can be removed to make more space. It's sort of like what happens to a pretty common storage space for all of us over time. You've got tons of boxes and random stuff in there, but not a good idea of what's in there or how important it is. Have you ever tried to move with a messy garage? How about get a project done that involves use of the garage space? Before you start, you have to clean stuff up or find the right stuff in that mess somewhere. You have to take stuff out and store it somewhere else if you want to store more stuff in there. And if you split the contents up, now you have two places that you're looking for stuff. And that's a lot like the storage sprawl that we discussed on this other slide. So as a result of this sprawl, Tony and his team are spending a lot of their precious cycles on managing both their storage and their data, and that leads to other priorities falling by the wayside. So they're spending their time moving or copying data, deleting stuff to make room for other things, provisioning additional storage, or growing their existing storage. And so far, they've gotten by. But Tony knows he's going to add infrastructure to handle this new job, or his team is going to drown in storage and administration tasks. So Tony thought it was time for some enterprise-grade shared storage. He came in to talk to one of his team members, John the sysadmin. John was a typical admin at a busy shop. He was often so neck-deep in problems. He rarely had time to do research or even have a forward-thinking conversation. Tony was actually lucky this time, and he found John shopping around for big, fast, scalable storage. So he did. And in their cursory research, they quickly found what they expected, that there's quite a few options for big shared storage. So Tony started thinking about Really Big Studios' requirement for this new storage system. Tony knew the first requirement, scalability, because he had a few systems that would not scale up in capacity. He had a few that would, but not gracefully. And before he and John could think too much about this, they were interrupted. At that very moment, Chris and April, both of whom had video to edit, showed up in Tony's office to tell him they had no remaining space on the high-speed shared editing storage. When Tony asked about moving some data to archive, Chris pointed out that their active archive system was also full. And despite their calm demeanor depicted here, Tony knew that this was an urgent situation causing work stoppage. So John had to stop what he was doing and go with Chris and April to deal with it. He had to move some data around and find some things that could be deleted. He had to adjust a couple of workspace or volume sizes manually, and at one point, he even had to ask Tony to come and help on some decisions for disposition of data. And that was a bit of a productivity killer because Tony's office is now totally empty. After this dust settled, Tony and John discussed the scalability requirement. John had read about some systems that can scale capacity without disrupting production or requiring a restore from backup. And Tony figured this was a pretty critical feature for their new storage, given the recent phone. Later that day, Tony and John were again talking about possibly scaling out one of their existing shared storage environments. And in their research, they found out that quite a bit of big shared storage can scale capacity, but performance scaling was a totally different beast. At that very second, Tony and John noticed a group of upset folks outside the door again. They saw Dave, the VFX supervisor, and Heejin, the VFX artist, and Kathy, the producer. And all of those folks were there to complain about one of the existing shared stores. Dave says, when renders and data transfers are running, I can barely get a directory listing. And Heejin says, when my workstation is taking way too long to save and load my work in these conditions. Kathy, who's kind of thinking at a higher level, is saying, this whole system is too slow. We're going to miss our deadline. So John had to go troubleshoot and hack to try to get Heejin back up and running. But Tony had to go with Kathy and Dave to explain to George, the CEO, why they're going to miss a deadline for a show. And these are not fun conversations to have. Visibly shaken by that previous meeting, Tony returned to his office, thinking about scalability. He decided that he didn't just need a storage system that could scale capacity, but one that could scale performance as well. Also, able to handle multiple workloads at the same time. He had heard many times about performance problems while that render farm was running and swore that the next storage system purchase would be able to handle multiple simultaneous workloads and scale performance without jumping through all sorts of hoops. So the next day, Tony came in and found John looking a little bit tired. He had his giant cup of coffee and everything. See, the previous night, John was on call and got an alert at 1 a.m. about failed disks killing performance due to a firmware bug in a storage controller. So he had been up all night dealing with the storage vendor. He spent all night explaining his environment to multiple support personnel and trying various things they suggested to recover. And the lack of sleep is making him pretty unproductive today. They revisited their requirements document. So reliability in the face of failure was clearly the next requirement. However, John was grumpy and a bit on a rant, and his lack of sleep and an evening dealing with overseas technical support was probably fueling his rant a bit. But he wanted to make good technical support a requirement for the next storage system. Tony thought this was a fantastic idea, given some of their recent support experiences. As Tony and John were discussing the merits of technical support and bulletproof storage, Dave stuck his head in the office door again. So, hey guys, I'm seeing these intermittent performance problems, but I can't really tell why. Sometimes things are just slow. I can't find any humans accessing the storage, and I have renders paused, but it keeps happening. So as John started asking Dave questions, like a good sysadmin trying to get to the bottom of it, Tony had a thought and called another one of his team members, Greg, into the office. Greg is Tony's DevOps guy. Greg is all about glue and automation and visibility. Recently, the powers that be had requested more visibility into storage capacity, so Tony had Greg build a system to go get it. Now, Greg's system works something like this. Greg's system walked all the directory trees in the facility and populated an external database with capacity data. And if you're not familiar with this approach, it essentially involves getting a whole bunch of directory listings and file size statistics and doing some math. And this works fine for systems with very small file and directory counts. But at least one of really big Studio's file systems was in the hundreds of millions of files range. And this meant that Greg's system had to visit hundreds of millions of files, and it took a couple of days to do so. And so frustrated several times by this view into the past of their capacity, Tony had Greg make the scanner multi-threaded so that it would complete faster. Now the problem with this is that a multi-threaded tree walker can start to compete with production I/O for metadata delivery, killing performance. And that is what was causing Dave's slowdown. So Tony got Greg to slow down the capacity scanner during heavy production. So Dave's immediate problem was solved. But Tony thought some more about this visibility problem and decided that his next storage system should be able to provide visibility into capacity utilization. He also thought he needed better visibility into performance. Better visibility into performance would help reduce his time to resolve when folks showed up outside his office door complaining about slowness. Later that evening, John and Greg were working together on a major upgrade to one of the core storage systems. They'd been forced to upgrade an existing system to a brand new .0 release of software. And they were being bitten badly by 2 bugs in the previous version of software, and they really needed one of the new features that appeared in this new release. So the good news was, when the system came back up, both of those bugs had indeed been fixed, and there was much rejoicing. The bad news is that drastic changes in the available command line tools broke some of Greg's workflow automation, and the feature that John really needed turns out to have slipped into a future release. That was sad times. So Greg went off to fix his code, and John went to revisit that requirements doc. So John thought it was possible to find storage that had higher software quality in production releases. He also resolved to find an organization that listened to users' priorities and developed accordingly. He wanted some more honesty out of the software roadmaps that various vendors had put in front of him over time. He really wanted to know how priorities of various roadmap features change as things change over time. Now, Greg's one request, remember, he's the DevOps guy, so his one request in this whole situation was for a storage system that was programmable and had well-defined APIs, instead of kludgy console output tools that were subject to change at the whim of the manufacturer. So Tony decided to give one of his existing vendors a shot at the business, so he invited them in for a meeting. They brought in this whole team, and they dazzled Tony and John with slides and a whiteboard discussion. Then they presented proposals. One of these proposals was to extend support on the existing system, and the second proposal was actually for a complete upgrade and tech refresh. And surprise, surprise, the second proposal was within 20% of the cost of the first and included tons and tons of line items. So just extending support was really a non-starter. Tony needed new gear, so he took a look at the proposal very carefully. Tony noticed that he was getting charged for software again, and that there were a ton of lines about software licenses and software support, not to mention hardware and hardware support. So why am I buying the software again? Asked Tony. Because our software licenses are tied to the hardware, said the sales team. You can't move licenses around. John asked, it looks like you're charging us for individual software features. Can that be right? Asked John. Yes, said the group of sales folks. That is how we license our software. So Tony offered them parking validation and concluded the meeting. Tony figured his next storage vendor had better have a more reasonable pricing and licensing model. The crazy support refresh quotes, this nickel and diming for features, and the non-transferable licenses were really getting old. So Tony and John felt like at this point they had really nailed down those requirements, but it looked like quite a list. They were a little concerned that they might be hunting for a unicorn. Could Tony and John possibly have time to do all the required research and find or craft a solution that would scale with them over time? You could see why Tony would be nervous. So why is he smiling? So Tony found Qumulo during his research. Tony's trusted integrator partner, GPL Technologies, brought in the Qumulo guys to talk about a solution founded on Qumulo core software that addressed all of Tony's requirements. So first on that list was scalability. Tony needed to be able to scale both performance and capacity non-disruptively while handling multiple workloads. Because of the inherent parallel properties of Qumulo's scalable file system, Tony and John could actually distribute the clients and workloads across many nodes, all of which were presenting the same file system. Each of these nodes had a combination of SSD and spinning disk used together in a hybrid model, allowing Tony to take advantage of the low latency nature of SSDs while keeping the cost per capacity with spinning disk. Furthermore, when the facility was running out of space on Qumulo, all Tony had to do was add a new node to the cluster. Once he added the node, the file system scaled out automatically and data got rebalanced among the nodes without disrupting production. So Tony went ahead and checked off that first requirement and moved on. Next on the list was reliability. So Tony wanted uptime, but John specifically wanted to be very well protected against disk or head failures. Qumulo's architecture is, of course, resilient against disk failures, and the distributed of the file system results in very fast and cheap drive rebuilds, minimizing those windows of risk. The data layout also makes it resilient against an entire node failure. So an entire node in the system can fail, and the system will remain in production serving data. This inherent high availability is a key benefit of Qumulo's scale-out properties. So Tony went ahead and checked off that second requirement. Third among the requirements, technical support. This was the subject very near and dear to John's heart. So Qumulo's whole approach to tech support is so unique, they actually call the organization customer success. If really big studios selected Qumulo, no longer would John have to explain his environment multiple times to different low-level support engineers. Qumulo customer success managers are highly skilled senior consultants with many years of experience managing very large storage environments. They would establish a regular call cadence to process any questions, problems, or requests that really big studios might have. In parallel, Qumulo would collect status regularly from a cluster installed at really big studios. And this constant monitoring would allow Qumulo customer success to react if they saw changes in behavior or component failures or nearly full file systems. But it didn't end there. Qumulo also has an online community where customers and Qumulons can participate in discussions about functionality, exchange ideas, or make enhancement requests. John got very excited about this. Additionally, Qumulo and their customers are publishing open source tools on GitHub for everyone to see, use, and extend. And this got Greg very excited because there were a bunch of sample projects already available on GitHub that he could pull down and start looking at immediately. John was pretty happy about all of this and did the honors of checking off the third requirement. So they moved on to the fourth, which is visibility into both capacity and performance. The Qumulo folks showed Tony and his team a demo of the real-time analytics available on Qumulo's web interface. From the high-level real-time capacity apps and throughput available from the dashboard to the IOPS hotspots view that provides visibility into where the I/O is flowing. From the integrated analytics holistic view of capacity and performance, where Tony could see at a glance the shape and performance of his overall file system, to the fact that these analytics scaled up gracefully to file counts beyond 10 billion. Tony and his team were blown away by the level of visibility to both capacity and performance that is built into this file system. They had never seen anything quite like it. Satisfied with this level of visibility on Qumulo, Tony checked off number 4 on the list. So the next 2 requirements were both handled by Qumulo's approach to developing and delivering software. So Qumulo is so agile that we had a user group before we wrote a single line of code. The very first thing our founders did was to build a research group and go ask 600 storage users what they thought about storage. And we got some pretty choice quotes, as you can see here, but more importantly, we got direction. And as we go, we continue to interview existing customers and new prospects about new features and priorities, continually making sure we are developing in the right direction. Qumulo's agile approach ensured that Tony and his team would have regular input into the direction of the product. Customer input is what drives Qumulo's roadmap priority. And we regularly survey customers about their needs and wants. Qumulo also shares design concepts about user interface and functionality very early in the development cycle so that we can make sure that the software delivered is what customers actually want. This helps Qumulo learn what to do next. Qumulo's product owners act on the customer's behalf in the day-to-day, so driving those tactical engineering and architecture decisions in the direction the customers want, and they adjust accordingly. And this team is doing this at a rapid pace, creating and releasing new software, that's the do in this diagram, every 2 weeks. So this development approach actually results in reduced risk for the customer. So you contrast that against most storage companies today who are still using what's called waterfall development. Waterfall results in very long development and release cycles, often between 6 and 18 months. And there's 3 pretty big differentiators between the 2 development methodologies in terms of risk and value. So the first is that the approach on the right of this slide delivers increased value consistently over time. With every of these 2-week releases, there are new features, new bug fixes, and new performance enhancements. And you compare that with Waterfall, which delivers one big chunk of value right at the end of the development release cycle. So you essentially get nothing until that release at the end. So the second thing is that risk for individual releases remains small because change sets remain small. Rapid release limits the size and number of changes that we can actually make in a given release cycle, and smaller or fewer changes results in lower risk on each release. And finally, the long-term risk to development direction is lower because our approach takes into account things like moving targets and changing markets. So it's easy for us to change our focus or our priorities every few weeks, and it's not so easy for a waterfall organization to do so once they've committed to a 6, 12, or 18-month development cycle. The whole team was pretty excited about this development approach. They actually started to use an agile development approach internally, but they had never heard of agile applied to a professional-grade storage product before. They checked off number 5 and 6. So Greg's only burning desire in this whole list was number 7, programmability. He really wanted to see an API to which he could glue his various systems. And it turns out that Greg was in luck. All of the data that was visualized in the analytics that he saw earlier in a demo was available through a well-documented RESTful API. In fact, there were already a bunch of sample applications available on GitHub so that Greg could get a fast start integrating his systems with the Qumulo cluster. Satisfied, Greg went ahead and checked off programmable and wandered out to look through some software on GitHub. So Tony finally came to the need for a sane pricing and licensing model. Could it be possible that they found a storage system that met every requirement? So we heard many times that people are sick of complicated licensing models, and we resolved to eliminate these ridiculously long and complex quotes and keep it very simple. So when you see a Qumulo quote, you will see hardware support, and software subscription. We don't show you additional lines for software support or feature-based licensing, and we don't tie the software license to a specific bunch of gear. We offer you subscription that provides max flexibility without brutalizing you with support costs on year 4 and 5 of owning the storage, like some of our competition out there. Tony was pretty satisfied after looking at a Qumulo quote from a systems integrator, GPL, and checked off the final requirement. With all these requirements met, Tony did a bunch of research on Qumulo itself. He was on the company. He was pretty interested in their technology, but he wanted to see what the company was about. Where did it come from? What was their focus? And most importantly, would they still be around in 5 years? So Tony found out that Qumulo was based in Seattle and had been around for a few years already. He found out that the founders were the primary inventors of Isilon's OneFS, which was a very successful scale-out NAS company and file system that got purchased several years ago by EMC. And in fact, the founders of Qumulo are named on the vast majority of patents that EMC now owns that were issued for OneFS. And Tony figured if they could do it once, they were likely able to do it again, only better. One of Tony's concerns was company longevity. He found out that Qumulo had no problems raising money because of who they were, the markets they were servicing, and their lineage. He also found out that they were seeing early success with major sales growth through 2015, despite launching partway through 2015, and this bolstered his confidence. Though they had just officially launched this year, last year, they had spent some time in stealth mode, gathering requirements and finding out what storage users liked about storage and what they didn't. So satisfied with the company's lineage and prospects, Tony checked some references of folks who own Qumulo to get an idea of the overall customer experience and some of the use cases. So he talked to a few customers with similar needs and workflows and was surprised to find out how much these folks enjoyed working with Qumulo. Customers like Blind and Zoic and Ant Farm and Photochem all had great stories to tell about their engagement with Qumulo so far. So with the requirements met, the research done, the references checked, what do you think Tony and his team did? Well, they purchased a couple of Qumulo clusters and ended up pretty happy about it. From the first meeting with Qumulo, the experience was among the top of all the vendors they had worked with. The sales team was very open and honest, which was a really nice switch. Qumulo's customer success team worked with GPL to install and integrate the system. Greg had a blast grabbing some samples from GitHub and integrating with the API. Getting his applications to talk to storage no longer required cryptic messaging or scraping console output. And John John was just ecstatic about the inherent high availability, the tolerance for failures, the ability to pinpoint performance or capacity hogs in real time, only everything, which was reasonable because for John, Qumulo was downright life-changing. So the job was underway and things were moving smoothly. Complaints about the storage had all but stopped. There were, of course, occasional fires to put out, new solutions to engineer, but Tony felt good about Really Big Studio's future. He went into George's office for another meeting and asked what they thought of all the work his team had done over the past few months. George and Jacques were extremely happy and also felt good about the future. And when they talked about the next project, Tony had no qualms, knowing he'd be able to easily scale to meet demand with Qumulo, and that Qumulo would have his back. So if any of Really Big Studio's problems sounded familiar to you, it's because they're extremely common problems to have. How many of you have felt like at least one of the characters in this story, Tony or John, or maybe Chris or Kathy? So I want to show you a couple of our appliances and then talk a little bit about how we at Qumulo think about storage, the things that keep us up at night, and kind of the reality we're working with. So we sell two appliance flavors today. There's a small size and a big size. The small size is the QC24. It is a 1U platform. It provides 24 terabytes of raw spinning disk capacity and 1.6 terabytes of raw SSD capacity per node. So your usable is in the neighborhood of 45 terabytes when you put together the minimum 4-node cluster. So this is a good balance of performance and capacity at kind of that 40 to 50 terabyte level. So stepping up, the starting point here is in the 400 to 500 terabyte range. So this is the second node type that we introduced. This is the QC208. This provides 208 terabytes of raw hard disk capacity and 6.2 terabytes of raw SSD capacity. And this gives users a higher density capacity optimized kind of lowest cost per gig. And this is a fairly high performance system because of the amount of SSD and spinning disk. All right, so I want to talk about kind of the hard reality of storage. This is really how we at Qumulo reason about storage, and these are the things that drive a lot of our architectural decision making and direction and vision decision making. So when we talk about spinning disks, you know, capacity has been going up pretty decently. So, you know, in 2002, an 80 gig disk at $500. Fast forward to, you know, Gartner and IDC are estimating that we'll see 20 terabyte disks in 2020 for $500. So that's a good sign. That's a very good thing. The downside is throughput is increasing, but not as quickly as capacity. So, you know, we can see the curve kind of leveling out, and I suspect by 2020 it won't grow too much beyond 200 megabytes per second. When we talk about drive IOPS, okay, 7200 drive IOPS, the story gets even worse because those have remained relatively flat and they don't show many signs of increasing. Now, SATA SSD IOPS are actually pretty interesting. Those are growing, and they're growing at a pace that is very satisfying. So we should be at 1 million IOPS by 2020. We've seen some technology out there that should make it into SSDs that are usable or other form factors that are usable by 2020. However, when we look at the dollar per capacity of SSD divided by dollar per capacity of hard disk, that's the ratio of the cost of SSD capacity to the cost of spinning disk capacity. It's closing, but it's not closing as fast as we all thought. Okay, we figured that those things would cross by some point in the near future, and now that does not look like the case. It still looks like we're going to be 6 to 7x on dollars per capacity by 2020, according to Gartner. And what's even worse here is when you take the average of all deployed capacity and you use those numbers, the IOPS per deployed terabyte is dropping dramatically, and that is a very bad sign. So these are the things that keep us up at night. How can we deal with those last two rows? How can we architect storage to deal with the facts in those last two rows? So when we look at throughput by the average request size, you can see the very top line there is SSD. Okay, so at a very, very tiny request size near the left side of this graph, it starts out at a very high clip, and as the request size goes up, it kind of levels out at a very high speed. So SSDs, kind of no matter what size your I/O request is, can deliver a pretty good throughput. Now you contrast that against spinning disk. One thing I want to show is that 15K and 7200 RPM disks are pretty close together, particularly for very large I/O. And this is a big driver that is pushing 15K kind of out of the market. The other thing to notice is that on the left side of this graph, the difference between SSD and spinning disk is gigantic. Okay, we're talking about 1,000x in terms of throughput at tiny requests. But once you move toward the right side of the graph, that story gets a lot more reasonable. Okay, so you're talking about only a 3x increase in throughput. Okay, that 3x is a lot less than that 6 to 7x of dollars per capacity ratio. So what we're trying to do is keep I/O requests to spinning disks near the right side of the graph. So the things that push I/O requests back to the left side of that graph, we've identified 5 really common things that push that I/O left, and they're things that we try to architect around. Okay, so the very first thing is fragmentation. A fragmented file system, even if you have a contiguous file that you're reading sequentially, if that file's scattered all over the disks, you're doing random smaller I/O, and that's a bad thing for storage. That pushes your I/O request size to the left on this graph. Another thing that does that is small files. So if we have a lot of small files and we're reading across them, the reads are going to look random by the time they get down to the spinning disk. That's going to push the I/O request size to the left side on this graph. You've got random I/O, okay, random I/O into a very large database file or a very large VMDK or something like that. That can push this the I/O request to the left on this graph. You've got per file data protection. So some other systems, you've got some other scale out systems and some object systems that do per file data protection. When those systems have a component failure, like a spinning disk, and need to do a rebuild, they are forced by their architecture to walk their entire tree. And what that results in is a very seeky workload, both as they're walking the tree looking for metadata, as well as reading those file chunks back. And finally, metadata scans. The metadata scan that Greg used in the story to get capacity information, I have seen metadata scans in a lot of shops that I visit as a strategy for data management. And so anything that does metadata scans is going to push that back toward that left side of the graph. And that is something you want to try to avoid. So we architect around some of these things. We have a separate data protection system at a block layer which takes care of some of these things, particularly per file data protection and small files. So when we go to do a rebuild, our units of rebuild are actually these contiguous 5 gig chunks on disk. And so when we rebuild a protection element, instead of seeking all over the disk, we're actually doing contiguous 5 gig sequential reads off of that disk to read data for rebuild. And we're writing data in 5 gig contiguous chunks. And you know that spinning disks love to be read sequentially, particularly over that larger range. Another thing we're doing in the small files space is we've chosen a smaller block size, and we've chosen not to do per file data protection, so that small files are actually handled a lot more efficiently on our system. In fact, for very tiny files, we can actually pack the file data in the metadata structure itself, in the inode, which actually eliminates one of the I/O requests involved in reading a tiny file on other file systems. And then finally, when we talk about random I/O, we are writing, data is always written to SSD in our system, so no matter how random the writes are, you always enjoy a nice low latency acknowledgement of that write. And it enables us to fulfill read data, hot data out of SSD as well. So random reads to data that is hot will also perform very, very well.
Thank you for coming in and saying a great story, a great presentation. It was very informative, and looking forward to hearing more. Thanks so much, Mike.
Cool.
And thanks everyone for attending. We'll be in touch with you shortly. Thanks.